Uh, Welcome. Thank you for joining.
Hey, it's my pleasure, Marcus. I think it's going to be my first experience with streaming, also. So
Oh, wow. Congratulations.
yeah, don't
Um,
know how good I'll act in front of a camera, but in live. But we'll try. We'll try it out.
yeah, I mean, it'll be fine. If nothing else, Twitch only saves the recording for like 30 days, and I've been having problems with the audio anyways, so there's a very good chance you won't even be heard. And then after that, it'll be scrubbed from the internet if you want. All right,
Oof,
so let's see.
that's
I'm
perfect.
just trying to make sure it looks like everyone can hear you. I'm just going to turn off the background music because it will flag on YouTube as copyright infringement. Okay, cool. And then I'm just playing actually one of your videos to the side because
Oh yeah,
uh, for no reason other than I tried to get. Also, wait, how do you say the name of the game? Bibites? Bibites?
the Bibites.
Bibbits. Okay,
Yeah,
see, I'm just
that's the thing.
yeah.
Yeah, I really shot myself in the foot by choosing that name. Honestly,
Why did you
um,
choose that name?
it's a French Canadian word that means like a small bug or a small
Ah,
insect or something like that.
I feel like you do say
Uh,
that in one video or something, or I remember
yeah,
seeing that
yeah,
somewhere.
exactly. In my first video, I think. Um, and like back in the days, it was just like something I was doing for fun. I uploaded the video, like, not thinking it would get anywhere. But now, kind of like a victim of my own success in some ways. Yeah.
Yeah, I mean, so I was saying I was gonna have an actual simulation going on here just because to fill up the screen, but my video card has decided to begin to die this past week, and it did not like both the Bibbits
Oh,
and OBS, the stream
I
recording, going at the
can
same time.
easily get take care of that then, maybe. Um, I'm just gonna have, and we'll have the benefit of using the most recent version that I'm currently working on. So
Oh yeah, yeah, yeah. Super exciting. I saw your basically to-do list today on Discord, which was very convenient because it had things I wanted to ask you about.
yeah, well, that might be my to-do list regarding like the next algorithm I'm working on,
Yeah.
because right now the Bibits is kind of using an algorithm that's loosely based on the neat algorithm, which is pretty known, I would say,
Hmm.
the community of AI and all that. Although it's not very used in real applications, um, but I figured that um, what you were referring to was the next algorithm I'm working on, which is going to be like a completely new um, yeah, algorithm.
Oh, cool.
But that's not what I was referring to. Um,
Yeah, so I
so
just had like honestly just some basic questions,
yeah, absolutely.
just about it, and I guess also welcome, Rad Nuggy. I should say see you in the chat. And I saw you on Discord say you were in the stream, so welcome to you and anyone else who's catching up. Yeah, so my name's Marcus. Should introduce myself. I go by Dr. N PhD. On Twitch, I'm a molecular biologist. I know nothing about programming that's worth anything. I call myself a genomicist, so I work in the genome. I know some basics of programming. I actually tried to build my own little DNA evolution simulator before I discovered Bibbits, and that failed. It didn't fail. It's just the only language I know is R, which is not very good for the simulation I was trying to do.
Yeah, R is kind of like more used in physics and all that,
It's
if I
like a
recall.
statistical
Yeah,
programming language, which is great for what it does. But as a It's like a simulation tool. It's very slow. Um, but yeah, I would love it if you just introduce yourself a little bit more and honestly just start with like where did Bibbits come from?
Yeah, it's kind of funny story. Usually, my studies were in electrical engineering at first. Um, oh yeah, and my name is Leo. Uh, I created like this small project, but that ended up blowing up, and like it's still kind of niche, but that basically tried to create digital life and like go through all the definitions of what life is and try to incorporate that and make sure that what I'm building, like the simulation I'm building, is actually alive. Um, so yeah, my background is in electrical engineering, so
Hmm.
it has absolutely nothing to do with all of this. Um, but yeah, I've always been fascinated by pretty much everything uh, related to science, life, and biology, etc. So during my studies, I was a little bored because, well, I was not one to study much, uh, but so I had a lot of free time on my hands, and I decided to just take some online classes on like different subjects. I remember taking one on satellite communication, on like geology and like just a lot of subjects. And I ended up taking one which was related to neural networks,
Hmm.
um, which I think it was machine learning by Andrew Yan. Like he's a professor at Stanford and pretty well known in the field of machine learning and all that. But yeah, I took this course, which was I'll have to say right now very basic. Like, don't think that this will this is the kind of course that would allow you to do like anything complex, but it just teaches the basics like of artificial intelligence, like just the feed forward principle and like detecting numbers, handwritten numbers, and all that. And I just figured like what if we applied this to like we gave like actual agents in a video game or something like that neurons and neural networks. So like the first very the first like let's say a version of the project had a very simple architecture, like five input neuron, five hidden neuron, six output neuron that controlled very basic things with like connections everywhere, like a very standard like a neural network, and just like randomize everything and see what pops off. And eventually I did reproduction, so they started like evolving and all that. And the more it went on, like I kept adding, I kept working. So it was very much like just a side project that I was working on, like in my spare time, just for my own pleasure. Uh, yeah, I remember like telling myself, "Wow, you're a big nerd on this," and especially like the fact that I was showing it to people around me, like my friends, and most of them were like, uh, "Cool. So are we going out now or whatever?"
Or do you want to stay home and play at work with your Bibbits?
Yeah, exactly. So the like especially when showing it to like my family, like my brothers or my mother, whatever, like they would just be okay. I don't get it, but nice, I guess.
And this project started in what, 2019? Is that the earliest date I saw? Or
No, not at all. I think I started this on 2016
oh, 2016. Wow.
or 17. Yeah, but like I said, it was very much like for the first few years, it was just like a side project that I kept going back to like every 6 months and adding something and like things like that. I think my first video might be from 2019, I
Yeah.
think. Um, but yeah, it was a long time before I got to yeah. That's yeah.
I mean, and then at some
2017.
point you started gaining like a player base. I mean, based on the Reddit and based on your Discord, you've got some people who are, for example, very obsessed with finding true predators, evolving,
Yeah,
or selectively breeding true predators, or something like that.
exactly. But it took a long time. I think like for even after like uploading my first video, I think it took nearly a year before I uploaded it publicly. I made a
Really?
few,
Oh,
yeah.
wow.
In the beginning, like I said, it was just something I uploaded to. Uh, I think I uploaded the first video, which was just like 1 hour of evolution,
Yeah.
like that I look back to, and it's like very bare bone and pretty much nothing interesting happened. But it was like trippy rock music, and just for 1 hour, and people like wanted kept commenting like, I want to understand what's going on because in fact when I go back to watching it, like pretty much nothing is going on. It's just Bibites like being buried and going forward and dying and things like that. But
Seems like
uh,
that's even now what the majority of them tend to do, at least
yeah,
at first.
yeah, exactly. For the first few hours, that's absolutely what happens. Um,
I just paused, by the way, just because in this video that I sort of randomly pulled up, it just happens to show the
yeah,
genes. Um, so where did you like? How do I don't even know how to form this question. Where did you start, and then when did you think, oh, you know what, uh, brain mutation sigma, that's going to be an important gene to to program in. You know what I mean? Like how quickly did this balloon out into this really impressive set of traits?
it was pretty random, I would say, in the sense that I remember the first one, like the first few ones being like size, speed, and color.
Yeah,
Uh,
makes sense.
yeah, exactly. Um, and it took a while before going anywhere further than that, because eventually, yeah, at first they didn't have any vision, so that took a while to add in. But yeah, I'm going through the list and um, think it was a like I won't say that this is even now an intelligent list. Like it's pretty chaotic. Like a few settings don't do anything. Like a few genes like are very archaic in the sense that they are not used that much, especially like all the genes related to laying eggs, like
Yeah.
the lay time, brood time, and hatch time. Like they're pretty much just random values that are then used to calculate like the size of the maturity at which the bibit will hatch, and
Yeah.
then that then decides like how much energy does a parent need to invest to create an egg, and yeah,
Well, I mean, I feel like you're selling yourself short. I mean, that's exactly how real evolution works.
yeah,
A
exactly.
new
But
gene doesn't appear with a purpose. It just sort of appears
uh,
semi randomly. And I
yeah,
mean,
fair enough.
have enough simulations worked or gone far enough that someone's had the time to point out that, oh, an interesting, set of combinations occurred where suddenly that hatch time, that's the key that makes something work better than all the
Yeah,
other
yeah,
bibits.
exactly. But I would still like it to be more like structured and like
Yeah.
interpretable because right now, like I said, like except for like lay time and hatch time, those are pretty straightforward. Like lay time is like the timer on which like the bibit will lay an egg. So like this one right here will try to lay an egg every 23.67 seconds,
Hmm.
and then once laid, the egg will take 10 seconds to hatch. But then the brood time, this one has absolutely no like, it's a brood time. It's called the brood time, but it's has absolutely nothing to do with time. So it is just used in a calculation um, to like I said, decide what's the birth maturity going to be.
Yeah. Do you have any like do you have a list of genes on a sticky note somewhere that you want to add or you've thought of adding but you don't know how?
Well, um, there's a lot of them, but like one being um, like the clock speed. Like the Bibites have an internal clock system that
Yeah.
they are able to use, and a few like input and outputs in their brain that interface with this system. But one thing that I don't really like with the system right now, with the genetic, the way the genes of the Bibites work, is that it's very rigid.
Yeah.
Let's say that they have an internal clock, but then they can only have one. So what I'm trying to do with, I was mentioning like a new algorithm I'm working on, is having a completely modular system that would allow, let's say, the Bibites to evolve any number of internal clocks, each with their own genes and so on. Um, so yeah, it just that's just the thing with the present system, is that I find it too rigid, and um, I want to uh, allow like pretty much evolution to be unbounded.
Yeah. So
Right?
that's something I've thought a lot about personally, but how I don't even know how to conceptualize how you would program in a framework where true evolution happens where you get a gene that you didn't program that has values and meaning that you don't know or understand. Right? Like can't is that
Yeah,
even possible?
that's the thing I'm working on, and I believe that it is, because like let's say we have um, right now, I was talking about modules, but modules basically would just be like a small package that contain uh, input neurons, output neurons, and genes,
Yeah.
and that would like have an activation a function, an internal function that would run some computation, or anything like that. So what I'm trying to conceptualize and trying to build the actual code framework to simulate is that you have properties in the world, um, and you have predefined modules. So let's say we have like the internal clock module, then you could evolve multiple of these and use them for different purposes. But then um, you can use those modules interfacing with other modules and other things like that in order to create new modules that are basically just encapsulations of multiple modules and functions
Yeah.
that it can be like let's say they use a complex like a module for producing pheromones with the internal clock that produce some kind of periodic I don't know, periodic production. Then they would be able to like modularize all that and then evolve new modules of that kind. So that's the like in the same sense where you have an eye, you don't have to evolve like each eye independently. You're able to um, pretty much evolve both at the same time, or if you already have an eye, then you can pretty much evolve a new eye pretty easily. You don't have to like evolve the whole structure
Yeah.
again and again. And the other important thing is that, like I was saying, there's like universal properties. So let's say you have a temperature, size, you have
Mm.
uh, properties like that. Then having, um, let's say, generic modules that would be able to reference like any type of properties. Let's say that your vision system, you're able to look at someone and you're able to like identify an individual. Then you would be able to like evolve modules that would um, try to extract, like to identify any properties of that individual.
Yeah.
Like so the thing is, being like with everything, when you want to program like artificial life simulations and all that, you want to be as generic as possible. Like
Mm.
that's why maybe what I'm saying is uh, maybe what I'm saying is very nebulous, but that's the
No,
thing.
it. I mean, it
Uh,
it makes sense. Right now, the Bibbits, they can kind of see. Right, I think they have a way to see each other, or they know the angle of a Bibbit nearby, or something. I don't quite
yeah,
understand
the
exactly.
visual system is another thing that's really lacking in my
Yeah,
sense. And
but but
that's very too basic.
but what
Like
you're
I can't see.
describing is achieving um, complexity by simply layering on
Yeah,
bit
exactly.
by bit these what you've said, like universal parameters that each
Mhm.
simulation, like, you go in knowing that you have. But wow, that sounds that sounds extremely complicated and so much different than what they are right now. I feel like these
Yeah,
future
totally.
Bibbits are going to be
But yeah, that's probably like years years ahead. But
Bibbits
yeah,
2.
yeah, the Vivids too, exactly. But yeah, I'm starting to like program the algorithm and like the basics. Like I have pretty much like the concept of modules and nodes and connections and simulation. All that I think I managed to pin down and it works. But now I have to add in like pretty much the whole biological side of things,
Yeah. Yeah, so what
because
sort of biological considerations do you make? Or I guess you said you've started small and now you're making this quantum leap further
yeah.
on. Where's your headspace at in terms of the biology?
Well, like I was saying, the secret is staying as generic as possible and giving the opportunity to for Bibbits to interface with the world in a like simple but like again generic enough manner.
Hmm.
I want Bibbits to be able to interact with the world, to interact reliably with the physics and all that in a way that makes sense and would allow them to like, build upon it and all that. One very important consideration that I try to have is the conservation of energy,
Oh,
um,
yes.
because that's like when you want to try and like manage the size of and complexity of a simulation. Um, it's very important to not let things blow out of proportion. Like the first versions, I think in my first videos, I present like the system where I would like try to have like pretty much a PID, I think it's called in English. But basically, I try to control the amount of bibits and tune the amount of plants I spawn depending on like the quantity of bibits, but the amount of the speed at which bibits are reproducing and all that. Try to keep them at, let's say, a target value of 200 bibits maximum.
Yeah.
But yeah, now it's a lot more unbounded, and the only thing like controlling the amount of bibits is the total amount of energy in the simulation. So that's like one of the major parameters that you have to tune in order to get a manageable simulation that will not like melt your computer.
Yeah, I suppose. Um, too many Bibites are probably pretty bad for most people's at-home computer.
Yeah, that's at least that's one thing with the new algorithm I'm working on. Like I'm maybe again I'm biting more than I can chew, but in addition of making it like a completely new algorithm, that's probably going to be like um, I don't want to say revolutionary, but maybe I don't know. We'll see.
Maybe.
But yeah, I'm trying to implement it in a new programming framework, which is called like Dots ECS from Unity, which allows to pretty much have um, code that can be multi-threaded by default. Because right now, like the Vibits is very unoptimized.
Okay.
Like it runs on a single computer core, doesn't use the graphic cards at all, and all that. So it's it's very very bare bone and very bad at being at running efficiently on your on anyone's computer. So um, I think that's also another thing is going to be coming from then. It's going to be very useful.
Mm. Um, I had a question. Oh, right. One thing I was going to ask about future versions, just whether or not you are going to ever consider sexual reproduction. Because right now
Yeah,
they just kind of make little carbon copies of themselves. Have you
exactly.
thought about jumping into that mess?
Absolutely. In fact, it's one of the like I have someone that helps me a lot with programming, but other stuff as well. Like from a few hours per week, let's say they will help and one of the things that they wanted to tackle. Uh, his name is Alex, by the way, but um, um, I talk about him already in a few videos. But it's basically I try to focus on the things I consider the most important
Yeah.
uh, for the simulation, and Alex basically just helps out with things that interests him or things like that. Um, he was the one that developed the expanded brain panel,
Yeah.
like allows you to pretty much have a better view of the brain than the small window gives you, and especially when they are very complex ones. Um, but yeah, one of the things is going to be work he wants to work on next is sexual reproduction and lineage tracking. I'm
Oh,
probably
yeah.
going to help around with that because I agree that it's very important and it's going to be very a very cool tool. Um, but yeah, I agree that sexual reproduction is absolutely uh, important, like especially in the field of biology. Um, like pretty much sexual reproduction is something that co-evolved, like that evolved like so many times in
Mm.
the tree of life just because it's so powerful.
Yeah.
um, but yeah, it's just I've been putting it off basically because for so long I didn't have a good idea of how they could reproduce like physically,
Yeah.
like and like what would the because actually the algorithm would be simple enough, but I just figured that I didn't have a good enough idea of how they could mate like physically, like to, with
Like
one
bump into each other.
yeah or something like that, because um, I actually had sexual reproduction like in the beginning, like very very far ago,
Oh,
long
yeah.
ago.
Huh.
um, in fact that when I was mentioning like they had a very rigid brain,
Yeah.
like a very like a fixed neural network structure. Back then they had sexual reproduction because like, that was very easy. Pretty much the only genes and brain they had was like just use the weight of every connections and blend between the two or choose one or all that. So it was very easy back then, and I was back. The thing too was that they didn't reproduce themselves. They I pretty much just took a bibit and copied it somewhere else.
Mm.
So that was reproduction back then. So it was
Yeah.
very easy to just okay, I take two bibits, I reproduce them together, then spawn it,
Yeah.
and that
Radnuggy
was
mentions broadcast spawning, males traveling over eggs, and coupling as just a few of the options for
yeah.
mating.
And in fact, me and Alex have been talking a lot about that and the options we had in the last few weeks. And one thing, yeah, like Rad said, um, I, because the thing is that I want the system to be flexible,
Yeah.
like I said, but it's very hard to formalize. Like, would would there be just like two options or three options, and they have to choose from one of those, or would the would there be intermediaries between the three?
Yeah.
Like, what kind of that's the kind of things I'm juggling with pretty much,
Yeah. I mean,
because I don't want to just be like what we'll probably end up doing is just choosing one system and going with it,
yeah.
because I it would end up too complicated for um, the version that we are anyways like eventually leaving behind.
Yes.
Uh,
Yeah.
but I would like to try and formulate an idea that would allow like to shift between different like um, reproduction types and allow like individual species to like let's say start from broadcast spawning but eventually like getting to live birth through evolution,
Yeah.
uh, in a continuous manner, if that makes sense.
I mean, um, oh, Rad has a suggestion. You could design it where it's modular, where you have a sperm and a gamete, uh, and they have a few things they can do with it, like pheromones. They can do how they wait. They can do how they do it, like how niche partitioning happens. So, I mean, I had sort of like I think a similar sort of comment where in real evolution, the broad range of reproduction that we see in animals often has
Mhm.
to do simply of egg retention, of where's the egg fertilized. So, I mean, I know you're designing a whole new modular system that I'm not going to pretend like I understood exactly what you meant, but if you went with your system now, it was just gene or egg retention value, and that's how long an egg stayed inside of a bibbit before it needed to hatch or it was gonna, die or something like that. Oh, and Rad is
Yeah,
saying some more things.
yeah, but well, that that's the kind of things we're juggling with.
Yeah, I bet. I
It's
mean,
all yeah, for sure. I think that having at least the liberty to this a system of like sexes and all that would make a lot of sense.
yeah.
And
So does
being
that
able to
mean also you are going to have to? Are you going to track species or similarities in a way that allows only very closely related bibbits to mate, or are you imagining it still to be a little bit more of a free for all?
no, in fact, you don't really have the choice when it comes to um, sexual reproduction because the thing is that most like if two species are too different, like the brains of two individuals are too different,
Yeah,
like having like allowing sexual reproduction between the two would just mean like wasted energy and like basically producing an upstream that we know will not be livable.
yeah,
Um, so we could just leave it as a free for all and then letting the bivots like actually figure it out themselves.
sure.
But um, but I think I would cut the as soon as possible and just having this algorithm, um, like making sure that two individuals are close enough, yeah, are close,
Yeah.
are related to allow like the fertilization to happen in the first place.
Yeah. I have a follow up sort of biology question, or a question that's coming from some biology.
Yeah.
Um, so does that mean when you have, or in your thinking about how this is going to work, is the offspring bibit going to be an average of the two, or are you going to take more of a, because that does not happen in biology.
Mm,
Offspring are not simply the average of the two parents. If that were
exactly.
true, then over millions of years we would all become more and more similar, despite a certain amount of mutation. Um, yeah. Do you understand my
Or
question?
yeah, for the genes themselves,
Yeah.
this would be kind of like a randomized weighted average, in the sense that you choose like a random distance between the two genes, and either it's like fully one, like the, I will say the male and the female, but for lack of a better term, but I don't think most of them will be hermaphrodite. I
Yeah.
don't know. Yeah, but it's the first. It could be either like exactly the value from the first, or between the two, or exactly from the second one, and or anywhere between those. It's more complicated for the brain because
Yeah.
um, they can have like mismatching structures and all that. But with tracking, like you can track the innovation, uh, or basically like, are two connections in the brain the same connection, or
Hmm.
did it evolve separately? Um, and by doing this, you can easily like match every structure that are the same. Let's say a bit has like are related enough, then you know that all those connections are the same. But then there is a mismatch on, let's say, three connections. Um, then you can do again randomize it and either take like a sum of all of them, none of them, a few of them, and things like that. So the thing is very much randomizing it, but I agree that it would be very interesting also to let the Bibites themselves control like which individual gets a bigger part
Yeah.
of the transmission. Um, Again, that's one thing that I would like to let to give them the control to.
Yeah. I don't know if you were aware of this, but that happens in real life, like
Oh yeah,
biology. Like
absolutely.
certain chromosomes are more selfish than others.
Yeah,
Um,
absolutely.
yeah,
And
I
in
don't have any advice on how to program that, but it's cool that you're keeping this in mind, because that would be
ah
so cool if you could get that to evolve in a simulation.
yeah, absolutely. And even more so, like um, that's for further down the line, but like having some parameters of of a bibit that would be determined during its growth or its hatching process from the environment. Let's say it sees well, the egg is exposed to such pheromones, then it could have an impact on, let's say, the expression of certain genes in the
Yeah.
bibit during its life. Or like if we end up adding temperature, um, like having kind of like reptiles where the I think the temperature determines the sex of the individual, and things like that, that would be very interesting. Or even like kind of like ants, like when the queen lay eggs, she decides what kind of ants, like
Yeah.
workers or warriors, or she will produce. So that would also be very cool. But
So you're talking about epigenetics. So you're going to
yeah,
overhaul how their genetics work, and then you're also going to add epigenetics on top of that.
yeah, that would be very cool. But again, I don't want to make the mistakes of saying that any of this is definitely something that
Oh,
uh,
yeah,
is going to be in the game. But it's all things that I want there
yeah.
to be. and that I would like to uh, make sure that are possible. Like I said, because of the generosity of the systems, because I want the systems to be as generic as possible to allow that kind of things. Because I always prefer to create systems that can allow certain things to happen instead of making the things I want to see happen themselves.
Yeah.
When, especially when programming and all that, um, when I'm working on the Bibites, I get a lot of suggestion like make them so that they don't eat their babies, but I don't want to hard code something like if this is my baby, don't eat it. I don't want to hard code things like that on the Bibites. So
but
I
but
always
you
prefer going the way of sorry.
but you want to encode or code the framework so that a Bibit could
Yeah,
evolve that behavior.
exactly.
Wow.
So that's always like the way I'm going at it. But the other thing is that it's it's always complicated, complicates things a lot. So that's like
Yeah.
the bane of my existence is that I'm like, well, that's very cool, but now I don't want it. I don't want to do that directly. So how can I make something that would make that possible?
I see. I see.
Um,
But you have to be careful as to not accidentally make it happen too often, right?
yeah, and even like in many cases, I even like go too far in the sense. Let's say that talking about predation and
Yeah.
in the Bibbits, like it's very elusive concepts. I know some people have managed um, to produce like existing like predators through very specific like settings combination and pretty much crafting the right ecosystem and environment for them to be viable. But let's say in most basic simulations, predation will not depend by itself. So I wanted to add predation. So I ended up creating a very complex system with diet and digestion and different materials and all that. And just I wanted there to be the opportunity to for
Yeah.
predation to develop, but it rarely happens. So that's one of the shortcomings also is that you not only have to make it possible, but you have to make its evolution possible. You have to create like an evolutive pathway toward those things, and then it becomes a very complex uh, design process.
Yeah. I mean, I can see, yeah. See, that makes sense, more sense now because when I jumped into the simulation or game, I don't actually know if you do you call it a game or simulation.
Mm,
It feels a little bit like both, depending on
yeah,
how hands on I'm being that day.
exactly. So um, it's kind of both, yeah,
Yeah,
in the sense that I'm slowly trying to gamify it and add
sure.
more like interaction and giving people more control.
Yeah.
Um, but for now, like there's a lot of things that you don't have control of. Like you, for now, you can't spawn food yourself. You can't place food.
No.
You can change. You can choose how fast food grows in the environment. You can move food around that's already spawned, but you can't place one from nothing yourself.
If I could argue against that, if you click the egg button quick enough and get enough
Oh, that's
baby
true.
bibbits to die in one area, you can make a lot of meat. So,
That's true.
so in a way, so Rad says predation is super very hard to determine because does a bibbit eating a random bibbit equal predatory behavior, or does a bibbit who grabs onto something and kills it and eats, does that equal predation? I think regardless, it goes back to what you were just saying, right? You've made this system, and this is what I was saying when I first jumped into the game, of like it was very clear that predation was allowed, yet I never saw any predators.
Yeah.
You've set everything up so that given enough time and the right circumstances, that either of those two outcomes that Rad is mentioning with the way evolution works is if that is more advantageous than their neighbors, then they will go down that route and become something that is more directly a predator.
Correct. So yeah, that's the hard thing so far, is that I've designed systems and like the dynamic that allows predation to exist, but then I didn't manage to find the right balance
Yeah,
of environmental parameters and all that that makes it viable in itself.
yeah,
um, and that's a hard thing. In fact, I pray like to the forces that may be that one day we'll find the right perfect like parameters that will allow all of this. um, in fact, at some point, uh, I should probably follow up on that, but at some point I had someone that wanted to do their master using the Bibites and pretty much doing that, like doing a sweep of all the parameters to find like what what are
ah,
the islands of life and what parameters are not compatible, and like if there's like sets of settings that are more interesting. But he ended up like writing something and sending it to me, but it was just for a few settings, like the basically what are the settings that allow life to like stabilize the more rapidly.
yeah.
That's the ones I've been starting I've been starting to use. But it would be more interesting to go further and try that approach uh, for like
Like,
what
uh,
kind of settings manage to produce and let predation
yeah,
evolve.
like a
I guess
high
that's
like a high throughput screen of your own simulation to inform how we all understand how it works, right? That seems very strange. I mean, already you've created something that even you don't can't fully understand the consequence of, changing every little
yeah, exactly.
parameter.
Like I have an intuition, but
Yeah.
very often I'm I'm like I'm trying out a few settings to like test that I manage to like to that the range is good and that things in that range is good enough, and the things that will eventually like evolve are just like so weird. I'm like, oh, okay, I didn't think that this would happen, but
Yeah. Are So a follow up to sort of the predation. So the other side of predation is not photosynthesis, but my question is, have you thought about putting in the capacity for photosynthesis to evolve? Because right now the bibbits depend on their ability to move to eat. Right? If they don't move, they generally are kind of, well, they flounder and they die. Um, is that ever on the horizon as sort of an alternative strategy, a third strategy?
um, I I've seen this suggestion a lot, but so far I've never seen like the um, what interesting dynamics this would bring to the simulation.
Hmm.
Like I try in general to like uh, envision like if I add a system or a dynamic or something, what will it bring to the simulation,
Yeah.
and like how much more interesting would it make it? Like that was my approach with like pheromones. I say, okay, this is the first form of communication. It could make a lot of very interesting happen. Um, but that's the thing with letting like bibbits um, like use photosynthesis. Obviously, it would have to be a very low form of energy
Yeah.
as that it would not provide, and then it would probably not make bibbits that interesting in the
Hmm.
sense that they would not do much. They would pretty much just sit there because why would you move? and so and yeah, so um, I'm not close to the idea, but I just don't see um, what interesting dynamics it would bring.
And actually, I guess now that you're saying this, it does make sense because of what you said before, where one of the most difficult considerations you had was the flow of energy. And I
Yeah,
guess if you suddenly start throwing in photosynthetic bibbits, they're throwing in more energy than perhaps is
yeah, very
is
likely.
desired, and the whole thing would blow up and melt your computer
Yeah,
potentially.
exactly. So yeah, that's one of the considerations. But as always, it's a very hard to figure out like those kind of things too, because sometimes you just have an idea and it ends up not working like you intended at all.
Yeah.
Uh,
Have you
I
had
think that
anything like that where you released it and then thought like, "Oh, that's leaving next time," or is it
oh,
pretty well tested by the time it's released?
most of the times, but yeah, there's a lot of things where I program something and then it obviously it doesn't work or like the Bibites end up like exploiting in a way that I didn't understand. Like I think in my first video about digestion, I showed a few of those examples where um, I programmed like it so that Bibites would be able to take chunks out of pellets, so
Oh.
that like they could bite some chunks of the plants and all that. But then like some bugs, I don't know how, but some bugs like crept in and Bibites were able to create matter where they would like cut the plants and then it would leave the plants. But then if I tried to like split the plants myself through code, then it was working, like the conserved mass. But then the Bivids themselves uh, managed to find a way to duplicate matter, pretty much. So that's the kind of things with evolution simulation is that if you have like some faults in your code or things like that, you almost always end up with like species that exploit those
Yeah.
faults. So you have to be very
Yeah.
thorough,
Which, by the way,
especially
that's
with
very
coding.
cool that that happens, but it's very annoying if you're trying to make a stable simulation that's
Yeah,
more real,
exactly.
somewhat realistic.
Yeah, exactly. So you have to be very thorough, and sometimes it's just like going through the code that handles like splitting pellets and does all the end shaking to make sure that all the amounts make sense. Because let's say that okay, a bibits want to take a bite out of a pellet,
Yeah.
then okay, what bite, what the amount does it try to bite? Does it tries to bite off? Like let's say it tries to take um, one one unit cube uh, square. Yeah, 1 unit square of matter. Well, first, does the pellet contains enough amount to allow that? Okay, and then does the bibit stomach can receive that much amount? And so there's a lot of like values to take care of and like make sure that everything works out. So when trying to debug that kind of thing, it's very complicated. You have to
Yeah.
go through everything pretty much too, and so many times you see something happen in the simulation, like I was mentioning, like
Yeah.
Bibits learning to duplicate matter, and then you have to go through the code and figure out, okay, where does that happen in my code? So yeah, when trying to do like stable and um, like systems that follows the laws of physics
Yeah.
and like the laws of thermodynamics and so on, there's a lot of places where that kind of thing might go wrong.
Yeah. I
So
yeah, I bet. Um, Although I hope that it's at least less often now,
yeah,
right? I'm sure at the beginning it was a lot of trial and error to an extent while it was still in the just sort of fun side project stage.
yeah, absolutely. It's at least now I know like the few pitfalls to avoid and
Yeah. Do you
those
know
kind of
um, what is like the big? So it sounded like you want to put a lot of optimization into the game sooner rather
yeah.
than later. But do you know like who has run the biggest simulation? Who has access to the best computer and the biggest, the longest? Because on your videos, like the one that's on here right now. I love the ones where there's multiple islands, giving
Hmm.
multiple subgroups that can sort of pop up. But
Yeah.
if you has anyone pushed the game to its absolute limits that you're aware of?
Hmm. Um, I remember a few people, like one person telling me that um, they had put like they mounted the TV with the spare computer um, in their salon. I forgot an English word. Their living room,
Yeah.
and let the simulation run continuously, kind of like an aquarium. So that was kind of cool, and like he kept like posting um, follow up, and I think it ended up going to 1,000 hours.
Wow.
Uh, at some points. Yeah, I remember. But that wasn't that much of a like. It was a pretty small simulation in comparison to lots of people, but it was very long running, especially since it was just always there. Like for weeks and weeks, it just kept
Yeah.
running, and like so that was very interesting and fun to see. Um, uh, right now, there's pretty much a limit on the size of the simulation that you can run.
Yeah.
The fact that the 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 program is not multi-threaded at the moment, like at all, and can only run on one single computer core, makes it so that even someone with a lot of money to burn, like, would pretty much not be that far ahead in terms of simulation size
I
and the
see.
number of bits that it can entertain and cultivate.
Yeah. I guess
But
because
I've seen people like having very big simulations, yeah, like up to the maximum settings limit. Um,
my computer
yeah,
just crashes when I try to do stuff like that. I have to keep it very, very minimal. But my question was kind of to lead towards the something I was curious about, which is whether or not you think, just with the system in place, there ever will be a plateau of evolution, right? Just that with enough, given enough time, a high enough population size, that there's enough pressure to make sort of the perfect, not really perfect, but the perfect bibit for the niche of the simulation,
oh,
right?
for sure.
So you
Yeah,
think that that absolutely can happen? It just maybe doesn't happen very often because people aren't keeping their computers on for 10,000 hours.
I think that might even happen most of the time.
Really? Okay.
Yeah, in the sense that you not necessarily like the perfect one, but oftentimes like a local maximum,
I
in
see.
the
Yeah.
sense that that they reach a point where they're just like good enough, and changing like in any way or shape makes them worse,
Hmm.
and that even like if better configurations would work or better behavior, then like the way to that better bibit would be like take too much time and make
Yeah.
it not successful enough so that um, it would die off and be outcompeted.
Yeah.
Um, so I think that's most of the simulations eventually stabilize toward that.
I see. Okay.
So
I don't think I I mean, correct me if I'm wrong. You can't change simulation parameters while the simulation is running, correct?
not right now,
Is that
not for
something?
the public version, but
Yeah,
you can now in the most recent like alpha versions for the Patreons and all
I
that.
see.
Um, I've started like it's quite. it's complicated to make like settings vary during game because
Yeah.
oftentimes a lot of systems like load the variable at first and then compute a few things before and then run. So you have to pretty much up, update everything when you change one parameter. Um, or you have to update a lot of things and a lot of internal variables and so on for every systems. But we're slowly going through the list and like adding a few that make sense or that are like low hanging fruits. Because yeah, that's for sure. Like if we want to avoid the things we were mentioning in the sense that um, like pretty much that evolution stops.
Yeah.
Well, we have either we need like big enough like simulation and
Yes.
like enough a big enough population that a few variations may end up like out competing and like there's a dynamic and there's enough separation that um, things eventually um, like are dynamic enough, or you can have a transitioning and varying environment parameters. So that's the two things that would allow like population to keep evolving and not stay too um, too static.
Mm.
Yeah,
Yeah. Cool. Um, it's been about an hour, so I just wanted to check in because I know you said that maybe you were only good for an hour, which is totally fine. So now's
yeah.
your chance.
Um, I might have to go eat. I was pretty in a rush today, so my stomach is starting to gargle a little bit. But yeah, I think I'm gonna be heading out.
Okay.
And
Yeah. No, that's understandable. Well, awesome. Thank you so much for joining. Um, I guess I assume people watching have either figured out the name of the game, the Bibites, or have looked you up. I mean, you have a website landing page, you have a Patreon on there, and if you donate to the Patreon, you get access to a Discord. So, oh, and then you
yeah,
have a Twitter account that I've seen, and obviously the
yeah,
YouTube channel that I'm currently right now been playing. So
exactly. Yeah.
let me just
So there's
so
a lot of options for
lots of
everyone.
options. Yeah, here I'll scroll down a little bit. So if you want to follow Leo at any measure, just search the Bibbits. I think it's the only thing that comes up. So you've got the name pretty much cornered.
That's true. It's not a very popular word, but yeah, I think I'm the main result in those cases.
Yeah. Okay.
So
Cool.
thanks a lot for having me, Marcus. It's been a very fun discussion,
Yeah.
and maybe if next time I might be still available for a longer discussion
Yeah.
or
Sure.
maybe
Yeah. I'd love to have you on sometime in the future, especially as you continue to roll out these really impressive features. it's, I had an idea of maybe where you were going with it, and I feel like you're so much high. You're aiming so much higher. It's really
yeah,
exciting.
maybe too high even, but
No, 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 not too high.
but I have time and I have motivation for now, so might as well go for it.
Yeah, absolutely, absolutely.
So thanks a lot, yeah, and
Yeah,
I hope to be available soon enough, and maybe we'll be able to run a simulation this time and discuss things in live at some point.
yeah. Let's do it. All right. Thank you
Awesome.
so much.
So,
All right. I'll talk to you later.
yeah,
Bye.
awesome. Bye.
Oh, oh no. Let's turn this off. There we go. All right. So my plan after Leo was gonna leave was to open up Bibbits and try to get a simulation going. Unfortunately, my computer has been very much not willing to do that. But I think I'll give it a try. I'll give it a try regardless. So I'm just going to go ahead and pause that. So I hope everyone who's watching at least got something interesting out of that. There is a lot. Leo could still be listening for all I know. He has so much planned. And I think it's hard to describe. So I've read a number of artificial life papers just out of pure curiosity. Actually, why don't I look up some? And the parameters of published scientific work, when people simulate life and evolution, it's always extremely rigid because it's hard not to be. Not to say that there aren't good simulations, academic simulations out there. All right, let me get something up. Actually, I wonder if I search on PubMed. Uh-oh. There we go. Okay. I thought I was frozen for a second. I am going to attempt to move to my normal screen, which will be completely messed up because of how Discord works. So give me 1 second. There. And I think this is going to die at some point, but that's okay. So he mentioned a master's thesis. It doesn't sound like it was actually written quite yet. But I do want to check that out and see if, just see. Bibites. No. Regulation of MLH1, MLH3 endonuclease in meiosis. That sounds interesting, but that's not Bibites. All right. Artificial life. Ooh. Oh. A programming language. Life is a verb. Okay. Let's look at this programming language. Look at self-organization and artificial life. See, when I was looking at these before, a lot of them were just perspectives. Like, here's a bunch of ideas on how we might be able to simulate this, how we might be able to do something cool with artificial life, but not actually anything concrete. I think what I actually might want to search instead. Okay, wait, let's see. In this review, we discuss the fundamental aspects of self-organization and list the main usages within 3 primary artificial life domains, namely soft, the mathematical computational modeling, hard, physical robots, and wet, chemical and biological systems. Oh, that's interesting. Yeah, so Leo's clearly, and Bibites are clearly within the soft domain. Didn't sound like he's planning on making any robots yet, but maybe if the game blows up and he gets a toy tie-in, you can get some Hasbro robots or something like that. All right. I don't actually want to read that. Let's see. Evolution simulation might be a better thing to actually search for. Oh, there I go. 1 second. There I am. the call died on me. All right, so simulating evolution in asexual populations with epistasis. That doesn't sound too dissimilar to Bibites. Simulating domain architecture evolution. Ooh, a simulation framework for genome evolution. That's cool. I'll look at that first. ALF. Let's see. So a user-friendly yet powerful web interface. Oh, okay, okay. This is promising. And it's dead. It's a dead link. This paper is from 2012, so maybe that shouldn't be too surprising. All right, so what are they doing? They basically just doing a range of evolutionary forces on genomes, nucleotide, codon, amino acid substitution, indels, GC content amelioration, gene duplication, gene loss, gene fusion, gene fission, genome rearrangement, lateral gene transfer, or speciation. Well, this sounds like it could have been cool. But not really doing much else. That's fine. Okay. Oh, the rare paper with one author who gets to say I. That's really cool. Oncosimilar. Let's see. So they define in this simulation, they define fitness. Oh, see, that's something that's really cool about Bibites. So there's clearly fitness involved. So in evolution, fitness is related to basically how many offspring a single organism produces. So if you're more fit, you have more children. Basically, that's very basic explanation. How fitness is necessarily determined is difficult to quantify on a gene by gene basis. So in simulating something that has a fitness value, it's kind of interesting that they say it's an arbitrary function. So that just sort of sounds like they arbitrarily are going to decide to simulate genes with various fitnesses. In Bibites, the way this is done is simply through competition. Competition and also how well any individual Bibite is able to move and get find and get food and that sort of thing. But there's no actual value associated to it. So this is it's implemented in R. Let's see. This one person really likes to publish about this. Let's see, what are they? An individual or clone-based forward-time genetic simulator for biallelic markers in asexually reproducing populations without spatial structure. Perfect mixing. Okay. So this person, wow. So this person is really just simulating evolution on a genetic basis. Okay. Well, that's interesting, but I don't think interesting enough for a stream. Let's go back to this, though. See if this is at all something to look into. So the ULAM programming language for artificial life. Let's see. Traditional digital computing demands perfectly reliable memory and processing, so programs can build structures once, then use them forever. But such deterministic execution is becoming ever more costly at large-scale systems. Should sound familiar. By contrast, living systems viewed as computations naturally tolerate fallible hardware by repairing and rebuilding structures even while in use. Okay, we currently know little about programming without deterministic executions. See, that is something. Yeah, and in architecture, where traditional models of computation, deterministic artificial life models, such as the game of life, need not apply. Yeah, so this is something that was very. I mean, I tried not to pretend like I even was following along with what Leo was saying, but the capacity, that's the thing that's blowing my mind so much, is the idea that he at least envisions and has these modules in some state of programming in production where they are taking this idea of fluidity and a sort of a non-rigid structure, non-deterministic execution of the programming behind it, and trying to use that for the Bibites so that they can evolve. So rather than starting with a place and sort of working within the bounds of something, setting the outside parameters and letting things move around inside of it, or something like that, which is basically how life evolves. We're constrained by physical limitations, which is something Leo is saying. You know, these they're not constant for us. It sounds like they're going to remain constant for the Bibites for at least a little while. But we went from single cells to groups of cells with and within our bodies we have cells with various functions. Those functions weren't determined at the start of anything, but they evolved to take advantage of the conditions and the laws of physics and the chemical interactions that are available to us as organisms at this time and this place on this planet. So they're talking about a programming language. Unfortunately, I might not. Oh, maybe I can get the full text. MIT Press Direct. This is from 2016. So, ULAM, a new programming language for research and development of indefinitely scalable, soft, strong artificial life. Software creatures embodied within some sort of digital machinery that produce benefits for society. Okay. Oh, the language of this, just the written language of this article is very interesting. As the hegemony of the CPU and RAM declines, for the first time in decades, significantly new computer architectures are appearing, such as the nothing but net neural architecture of IBM True North. All right, let's actually see. Let's see some examples, small ULAM examples. All right. Telomere. What's telomere? Oh, I know a little bit of R. I don't know enough to understand what's going on here. What's a quark? Well, I unfortunately don't understand this at all. That's too bad. I wonder if there are any things that. So, what cites this? ULAM. ULAM? ULAM language. Ooh. No one cited it. That's sad. All right, so that didn't really get much traction, unfortunately. Okay. So I'll go similar. All right. So I really, really do actually want to try and get Bibites working. I didn't want to try it while Leo was on, but I will try it now. I'm just afraid that this will all crash, in which case that's the end of stream. Which I guess that means I should say announcements now. Just that, so on Sunday, very excitingly, I believe, as long as schedules work out, David Hewlett, the actor who played Dr. Rodney McKay from the TV show Stargate Atlantis, although he's famous for many other roles besides that, he's coming on. We're going to discuss a book called The Genesis Machine. That's very exciting. Let's see. Okay, Bibites. Are you going to work for me, or are you going to crash everything? Hope not. Although it isn't opening. Get out of here. Let's see. Artificial... No. What do I search? If I search artificial evolution simulation... Yeah. See, these are all probably really, really interesting. But to a very small segment of the academic society. Using cellular automata to simulate domain evolution in proteins. Yeah, see, it's going to be, again, extremely important for certain people, but it's very mathy. I was looking for something I could open in a window. All right, Bibites, are you going to open? Please, Bibites, open. Oh, here we go. Ooh. Maybe. All right. Cool. So let's play around with some Bibites. I guess it didn't crash my computer, which is always good. Let me get this. There we go. I disappeared again. Nope. Just got to figure out where my camera is. There I am. All right, let's get some Bibites going. I'm also going to finally turn on the music again. Just so there's something in the background. All right, let's start a simulation. So I have these Bibites that I have been evolving or trying to evolve for a little bit of time, related to what we were talking about with Leo. I really would love some predators to evolve. It is kind of unfortunate that just the simulation as set doesn't reliably produce predators, but that's okay. So what am I going to do? I think I'm going to set the parameters of the Bibites to be more predatory, and they'll just kind of show up. We'll see what actually happens. Okay, simulation size. This all seems fine. I don't want to mess any of that up. I never, ever do anything with energy balance. Genes. And I always forget exactly which. Oh, diet. There it is. So I'm going to set it a roughly equal. Randomize. Oh, that's going to change a bunch of things. Ooh, let's make very small. Very, very small. They're going to be about equal. Metabolism speed is quite low. I am going to make them a tiny bit bigger. View angle. Mouth strength is going to be very high. Defense is up. Okay, we'll start these guys. So they'll kind of show up. Whoops. Not that. I want to place Bibites from file. I believe it's the Bibit I call dumb herbivore. Let's see. Yes, there we go. So these guys are pretty good. They are effectively... I sort of designed them to be basically big, slow cows. So that they will populate an area. They have extremely low defense. Very bad mouths. So they don't really attack. They don't really defend. And the point of them is to exist as little... Oh. Oh, that one's gonna die. Come on, eat the food that you gave. I'm just gonna artificially just kind of attack this guy. Oh, wow. Omega Ultimate, thank you for following. I hope you were here for Leo's interview / discussion. Anyways, so I have my big slow cows. And what I really, really want is that in my mind, if I have these big, dumb, slow cows, they're effectively energy sinks. So they're going around feeding on the edible green matter, right? But then hopefully, what I would hope is that a Bibit would evolve in this niche that I've set up, the niche being full of these slow, meaty energy stores. Okay, well, let's check out this guy's brain. Probably very dumb. I didn't send it. Okay, so yeah, plant angle. Is he actually digesting? Yeah? Well, as long as he stays stuck on that. I'm going to speed up the simulation just a little bit, as much as my stream can handle. I guess not my stream, my computer. There we go, that's pretty good. I don't know why there's a black bar. Oh, I see. It's just that window sizes are different. All right. So basically the next step in this is to wait, unfortunately. I think but I'm pretty impatient. So I just want to find if any of these Bibites have any sort of... All right, so that one moves away from plants. If I'm interpreting that correctly. I'm okay at interpreting Bibit brains. Very okay. I feel like, yeah. Essentially with the... Oh, that was pretty good, actually. With the... what I really need is to just get some of these to start breeding enough so that I can get a population with variation. The way I like to do that is just by cheating. Just by getting them to lay a lot of food or a lot of eggs. Because if I'm if I've interpreted how this works correctly, I don't believe this costs as much energy as actually laying an egg. All right. So, oh, he just moved. That moves in. Plant angle. He's doing something with his hidden neuron. That's kind of cool. It would have been smart maybe if I would have tried to get it to start at least with some neurons that push them to move towards other Bibites. That's kind of what I was hoping would show up. And I have had that show up before. It's just that those Bibites are never good at eating the big cow Bibites, who are themselves doing only kind of okay. Ooh. Something's wrong with this one. This one's sick. I don't think I've ever seen NAN for a neuron. I think that neuron basically, that means that neuron's basically dead. Are all of them like that? It's from generation 1. Oh, I see. Okay, I'm just misinterpreting it, I think. Well, we'll see. That one seems to have low vision. Yeah. I think I purposely set their eyes super close together. Again, I wanted the big green ones to be, I mean, look at this. They're ostensibly fighting right now, and they're just kind of not doing very much. I wanted the big green ones to be big, dumb, weak cows, basically. They are or sheep, maybe that's better. They are the food source for other Bibites. This one just moved into some meat. I don't think it's even eating it. Come on. There you go. I'm going to move these. I don't want them to fight anymore. Go away. Let's see. Gen 2. It's about to start dying, so I am going to artificially keep it going just by having it lay a bunch of eggs. Whoops. Oh, wow. That one just laid an egg. Let's see what this generation looks like. Still pretty dumb. This one's having a good time. Oh, wow. All right, not meat angle, but it's doing something really fun. All right. Eat some food. This is my method of Bibit artificial selection, is I just smash them into food until they get big and strong. Let's see, the cows are doing okay-ish. Although I could use some more. I'm trying to see if my little proto-predators. Oh, meat angle. Oh, negative though. Shoot. This one has a meat angle neuron. I just need it to actually eat some meat. Oh, it's going to move away from the meat. It refuses to eat meat. Except that it's... All right, this one I'm going to get to lay a couple eggs. Maybe that meat neuron will at least mutate so that the Bibite or the Bibites go and eat meat rather than stray away from it. See, this one's full of meat, full of energy. Yeah. Okay. All right. These other Bibites are actually... Oh, wow. Oh, is grabbing. Want to attack. I kind of like that set. I really... Oh, wow. Come on. Eat the meat. Fine. That's actually really great. I really like this. It moves away from meat, but this is grabbing neuron and wanting to attack. Oh, it's about to die. Shoot. It's dead. Hopefully these eggs will do something. Very similar. Come on. It's too small to grab. I'm trying to grab him. But now what? All right. He doesn't want to play. Was that my last chance? Did all the other predatory ones die? I think they might have. Well, that's too bad. That was a pretty quick evolution of neurons that I wanted, just not maybe behaving the way I needed them to. Ah, this one's completely different. Come on. They all hate meat, even though it's what they need. Come on. So I have some other saved Bibites that I had something that I saved as like a proto-predator. It didn't really work out with a couple more hours of evolution, so I don't think I want to really drop that in quite yet. I don't want to give up on these little guys. Going small for the predators seems like an okay plan at the very, very least. Meat angle, fullness. Yeah, I'm going to have it lay a bunch. I need variation. I guess sort of an issue. They all really like to grab. Their mouth strength, I think, is really helping them. Minute. Grab. Meat angle away. Number of Bibites. Accelerate. Okay. Still don't want to eat meat, though. Let go. The cows at least are doing okay. I thought this negative plant angle was going to be a problem, but just going to watch it for a second. Because it needs to eat. It hasn't eaten for a while. Come on. Now, I know this is clearly not the point of what Léo wants to do. talking with him is very interesting. It's now I understand more his like the purpose for this game, for this simulation. He really does want it to be very, very similar to how real evolution works, and that's super cool. However, I wish I had like a little CRISPR-Cas9 button up here to modify the genomes of these guys in real time. I know there's like a utility you can basically hardwire your own Bibit. I've seen that. I just haven't really played around with anything like that. Are these all just really old? All from Gen 1. Where's the maturity? Oh, I see. I guess not all of them are mature enough. Let's separate these two. Here comes a little one. Probably freshly hatched. Gen 1. Yep. Fullness. Okay, actually, I like this. I'm going to lay a bunch before he conks out. Yep. Doesn't know that he needs meat, unfortunately, because his energy is going down. Alright, that was it. Oh. Look at this one. What's he doing? Or why is he doing that? So, constantly negatively accelerating and constantly digesting. That doesn't seem good. Also digesting when it's full. That's probably better. And rotate towards Bibites. That is what I want. Oh. Rotate towards Bibit? Yeah. This is good. That's the behavior that I want. Oh, and he's eating. Oh, you're definitely going to have to lay. Oh, it's almost parasitic, actually. That's very... Oh. Oh. Okay. I got to pause. I'm going to save this. Something I didn't think about was the idea of a parasite. Parasite. Let's see. And they're really hurting this big guy. That's actually pretty great. I'm going to have him... Yeah, not a predator, or not a parasite, but... Oh. Oh, he got killed by his own offspring. That is, that's tough. Alright, do you have the same brain? Pivot angle towards each other. Speed is negatively correlated with wanting to lay. Fullness opens up digestion. Constant hidden acceleration. Okay. Is this one of those? No. That's a very dumb one. Do want this to attack another big Bibit so that I can breed this one. Is this mature already? Maturity time was... Oh, yeah, it's still pretty low. All right. So I think I can... Oh, that one took an egg. It's a little bit of this combination of having like a really strong jaw and being small and being attracted to other Bibits. and then having a meat-based diet. So, and then these things have a wide field of vision because their eyes are far apart. I think that's what that means. Yeah. Let's see how the big one's doing. Poorly. All right, that's pretty great. I just wonder if these ones I've had to attack manually. Also, I could use some more cows. So I'll move some of these around. There we go. All right. Were any still up there? No, because this is generation 1. That's not the right Bibit. Did I lose my Bibit? Nope. Here he is. Oh, they're a little fragile. Whoops. Now I got myself stuck in a corner where I can't. Oh, okay. Here we go. Here we go. So I won't touch it. I just want to see if it's going to naturally attack. No? It's supposed to rotate towards... I'm a little confused. I thought it was supposed... That means it's supposed to rotate towards more Bibbits. Didn't seem to react at all. You are 3rd generation. These really... Oh, well, I guess if I'm making them lay, that's how I'm getting quick generation times. And I guess I haven't looked at these parameters yet. So, meat equivalence 4 units squared. Energy is 10 energy per unit squared. Oh, yeah. These, yeah, okay. So these are functioning the way I expect them to. Hello? Why are you stopped? Now you have to eat. Now you have to eat the meat that you got. Some of its interactions may be hindered by its vision radius, which is shown in the second icon up left. View angle, view radius. I see, 51. I see. It's short or nearsighted? No, it's farsighted. No, nearsighted. It's nearsighted. It can't see very far away. Ah. I see what you mean. I don't know the right word, but you're right. Well, I guess I'm going to have to just force it to continue laying until some Bibbits of the appropriate set of genes, the appropriate set of neurons shows up. Because I like this as a base. In fact, I am going to put it again near one of these. Oh, yeah, yeah. Hey, you were right. Look, it slowly rotates when it's pretty close. But if it's farther away, nothing. Oh, wow. Nothing. Nothing. Very close. It has to be very close. Uh-oh. Oh, no. It actually died. Whoops. I'll find one of its offspring. This one looks good. All right, this is the new chosen one. Come here. It's not biting. I'll take this other one that is biting. Gotta find it some food first. I think they lost their grabbing? Did they ever grab? That one did pretty well. Let's get this to lay a couple. Oh, and check its vision. So the viewing angle is fine, but you're right. The vision radius is very, very small. At least compared to the cows. I never look at the vision. I don't yet have enough of a grasp to know exactly which set of parameters I need to be like checking at all times to kind of get what I want. You know, conversation with Leo, and now what I'm kind of seeing with these little guys, I should have asked about parasitism. I guess I'll have to ask him about that next time. Because if these little guys had a, I guess what would it be? A shorter, or so they don't take very much energy. If they had a short metabolism and they evolved to like latch on and just suck away some of the energy of larger bibites, I wonder if that form of parasitism would work in the current bibit sort of framework. Sounds like Leo's intention is that anything. Oh, it likes the egg. Oh. Egg predation. That's interesting. Well, then it didn't finish. It kind of seems like the problem with... Well, that was good. The problem with predation is that it requires that they not only attack other bibites, but they also need to actually get the food afterwards. See, these little grabby guys, they're pretty good at picking something up, even if it's not something that they are going to thrive on, like this one right here. And that includes attacking these bigger bibites just by latching onto them. The problem seems to be, though, that they don't actually grab the food afterwards. Yeah, so this one will kill it eventually. But it's not doing a great job at actually like, or the other ones have not been doing great jobs at actually taking the energy that they're sort of like releasing by killing these things, which is why I kind of wonder if I could go in and just edit them, if making their metabolism, like their grip stronger and their metabolism slower, if that would be enough to kind of get them to be little parasites so that they could survive and not actually kill the host. Okay, can I tell, is there please someone tell me if you're watching and you know. Is there a way to tell sort of like the amount of meat that they're chomping off or health that they're chomping off per second or whatever? Third icon. Thank you. Digestion. There we go, I think. In the third image, you have to select it. I'm missing something here. Thank you, Omega Ultimate, for helping. All right, I think the time delay is kind of just costing us a little bit of understanding. So I think I see it now. I just want to catch this Bibit, give him some food, so he stays alive while I investigate. Oh, cool. Come on. Rotate. Rotate and eat your prey. All right. So 0.7 energy per second. Nope, let's call it 0.77. Hello, Adrian3670. There's also a gene in the second tab for strength. You think it's related to bite damage? Yeah, strength. 23. Yeah, so it's hard to relate exactly like how much damage per second is being done due to that number 23. About to die. There you go. All right, this is a good Bibit though. Full thing. Yeah, I'm going to get this one to lay a bunch of eggs. Yeah, so I really want to, I have one of these saved, but I think what I'm going to do later is download that Bibit editor. And if I could turn down, okay, see, but does turning down strength reduce its ability to get energy? Oh, scared me. Thank you for the follow, Adrian3670. Yeah, if I can turn down its strength, is that going to impede its ability to grab chunks off of the Bibits that I want it to not predate, but what I want it to parasitize? Parasitize? Yeah, parasitize. All right, let's all right, first of all, I'm going to save you. Protoparasite 2. Generation by generation, they're doing pretty well. Okay, that one's about to fly off the map because it has very poor eyesight, as we've established. Put it on you. All right, the cows are doing fine. Yep. They're keeping up a little bit. My parasites, though, they still need a little bit. Oh, this one just naturally grabbed onto this one. I think. Right, I think I saw that. Where's your brain? It's pretty similar. Digestion. Okay. Is your eyesight any better? Your eyesight is not any better than the others. And you're about to go off into nowhere. That one's going to be dead soon. Oh, we've got some over here. Are they related? Yeah. From your understanding, they actually get bits of meat based on the damage they deal to their host. So in theory, you just need to do enough damage to barely be positive energy flow, right? Yeah, that's what I'm kind of gleaning from this too. Um, uh, exactly. It's like the little bit of balance. So in this particular case with these guys, their positive energy flow is, well, they have a positive right now, but they do. Oh, this one's growing. Let me find one that's not growing, like that one. Actually, it's dying. Hold on, hold on. I need this to eat so I can kind of see, because I'm wondering what just the normal like energy rate of these guys are. It needs to heal too. All right, we got to feed this cow for a little bit. But you're right, to like strike a balance, I need these big guys that I have to be little sinks for energy. And then little parasites need to deal just enough bite strength to keep themselves alive and grow and eventually reproduce. But not so much that these green guys are really affected. I think a little bit of damage is fine as long as they eventually heal. This is not one of my good ones. All right. Let's see. So they are very, very fast digestion. Minus 43. So actually, these guys are really efficient. They're really efficient at least using these things. These little green foods. All right. I gotta check and see if my proto-parasites died out. If they're like this one, they probably are. That's fine. I'll just load one from a file if I did. Kill them off. Yeah. Let's zoom out. I think I might have accidentally left them alone for a little bit too long. Yeah. That's okay. I need these cows to oops. I need them to reproduce a little bit more. I need them to colonize this area over here. The only thing about the bite strength, though, not the only thing. Another thing about the bite strength that I need to probably read up on. I know there's like some helpful pages out there for exactly what the genes do, or at least what people infer that they do. But whether or not the grabbing neurons are at all related to strength, I would have assumed they were. All right, I need some of those Bibites. I would assume they were related to, or grabbing was related to strength. And they need a tight grab, otherwise they are not going to actually grab on. They'll just bounce right off. All right, you had your chance. Come on. Random orientation. That one got hurt. There we go. Okay. This island's a little sparse in the middle. That's okay. All right. See, this one's, well, it should just be a clone, I guess. And see, that's why they might make good parasites, but not good carnivores. Just left all this meat behind. And he just flew into someone's mouth. That one seems to have gone to some meat. That one's okay. All right. This one's trying something. This is one of my originals. I feel bad for him, so he'll get stuck on there. Or not. Actually, also, is Bibit angle determined around a center point? Because this guy, he doesn't look until I get him very close. Oops. Yep, then he turns. But I swear when I was sort of putting him close to the tail, he wasn't... He's turning towards the center. Take some meat. All right. Forward is 0 on this one. What do you mean on is forward is 0? My cows very, very faithfully don't do much. Oh. Why are you going backwards? It's not the direction you should go. That's fine. All right. I'm almost tempted to put another species of bibbit in here. I have some... Oh, in the angled node, forward is 0, so they don't turn. Then a positive or negative value makes them rotate-ish. Let's see. So let me just examine that. I see what you mean. Yeah, I'm still learning how these neurons work. I read the like PDF that you can get that explains it pretty well, including the like functions behind it, like tan H, and then sigmoid and all that stuff. I read it, thought I understood it pretty well, and then I opened up, you know, the game a couple days later, and I only remembered probably 5 to 20% of it. It's complicated. To me. Okay. All right. So, unfortunately, I do have to stop streaming now. It's getting, yep. So 10 is my normal end time. So if you are here now but missed it, the creator of this game that I'm playing right now, the Bibites, Léo, he was on, he recorded the stream, I recorded the stream. It might end up on his YouTube channel in some format or other. Otherwise, you can find the VOD. I've been having audio issues, so it probably won't be on my Twitch channel, but there's a link to the YouTube channel that I drop improperly Twitch side recorded VODs on, so you can check that out. Very nice, very cool insights into the future of the game. There is so much architecturally planned for this game. I wasn't expecting that. It's great. I just hope he can accomplish like even 10% of what he wants. Anyways, so if you're new, thank you for joining. I normally on Wednesday talk more about science and science fiction. This is pretty science fiction-y, so that's great. On Sunday, like I said before, if everything works out, David Hewlett, who played Dr. Rodney McKay on Stargate Atlantis, is going to be joining me on stream. We'll be talking about the Genesis Machine. It's a book. It's about the history, current technology, future technology-ish of biotechnology, like genome editing, genetic sequencing, that sort of thing. And then there's also some fun scenarios about the sort of more far-flung future of like what we might do with that ever-evolving technology. So that's going to be fun. So David Hewlett is joining. Dr. James Gurney is also going to be on. So that should be a fun discussion. So if you're interested in that, come back on Sunday. So I might have to move my normal microscope day, which is normally Sunday, to next Wednesday. So we'll see about that. Yeah, this game has so much potential. It really does. I mean, so I only discovered it probably a couple months ago, and I was already really like excited by how much change had happened since, because Leo has recorded sort of iterations of this game on YouTube. Even just the evolution of the game via his records on YouTube was exciting. I had no clue that he. Let's see. How do I phrase this? I don't know Leo personally, so I had no idea what his plans were. I was going to bring up the fact that biology doesn't work with genes with a name called like strength or herd cohesion weight, right? Genes don't evolve to have a function. Genes evolve into a function. But Leo is clearly very, very, very aware of that and has these aspirations to build the box and let the simulation fill the box, which is super cool. So I really hope that works out, because if he layers the things as he was describing, there's going to be the potential for more than just the odd parasite or predator to evolve, but for really complex behaviors to evolve from essentially nothing. It's going to be so cool. Yeah, so I should probably let me get his website up and just put that in the chat. I think most people who are on right now might have just come from the Discord, or probably are familiar enough to know and follow Leo in some respect, but he has a Patreon. Go throw him some money. I do. Because this game is super fun to just sit down and watch and bump Bibites into each other. Or let sit on your computer for several hours and come back and see what happened. Alright, I don't think I want to save this one. These cows are the most perfect Bibite I've ever made. Perfectly fit to form. They're weak, they're slow, they're pretty good at getting food, and they're super energy dense. They're the perfect prey for that mysterious predator and or parasite to evolve to attack. Okay. So anyways, thank you for joining. Come back soon. Come join me, David Hewlett, and James Gurney on Sunday. Bye.
Which?
Dreamer of all the ancient knowledge.
Dr. Ben.
The experiments of Dr. Haynes.